This is a report of our first patients done on an FDA feasibility trial, 20 patients undergoing bilateral LASIK surgery and 20 patients undergoing bilateral PRK. We did the LASIK first, and those are the results you'll see today. One eye was randomly selected for custom cornea, one eye treated with conventional LADAR vision surgery. We treated myopes, hyperopes, and astigmats, but we're going to present the myopes because of time constraints. And there had to be excellent right and left eye agreement as far as their pre-op manifest refraction, cycloplegic, and wavefront maps so that it would be a fair comparison. We've only done 13 PRKs and very recently. There's no post-op data on them yet. So we will be presenting the 10 myopic LASIK patients with 3-month follow-up data available on all eyes. We recently received approval to expand this number, but we have not begun that yet. As far as the treatment parameters, everybody got an optical zone of 6.5 millimeters, and everyone got a blend zone of 1.25 millimeters in width on either side for a total of 9 millimeters, except the conventional LADAR vision spherical patients who had no astigmatism to correct. We had very standardized test conditions, which are necessary to pick up these tiny incremental changes. And we looked at their data in 3-dimensional wavefront map displays, as you see here. Here's a patient with astigmatism, as you can tell from the potato chip shape, all aberrations. And here you see the higher order aberrations, which are a subset of the map on the left. We also looked at 2-dimensional displays, as you see here, if you were flying above the maps and looking down. This is a typical wavefront after LADAR vision treatment. Total aberrations on the left and higher order on the right. Looking down into the blue bucket of myopia, you can see this is a myopic astigmat because there's an oval shape. And post-op, the RMS, or root mean square, which is a measure of the goodness of the wavefront, has improved dramatically. The number is much lower, and the closer to 0 it gets, the better. So we did a good job of getting rid of sphere and sill here. If we look at the higher order aberrations, the RMS goes from 0.14 to 0.25, which is very typical of traditional laser surgery today with any of the systems, where we at least double and sometimes triple or quadruple the higher order aberrations. So let's look at the first myopic patients. We did 5 patients in group 1 and 5 patients in group 2. Based on the analysis of the results of group 1, the algorithm was modified for the custom cornea eyes in group 2. And here are the pre-op parameters for the custom cornea and conventional eyes in both group 1 and group 2. Here's the sphere and the sill, and you can see it was a very fair comparison. The eyes matched. So here is the 1-month uncorrected visual acuity for the myopes on the left. And here is uncorrected acuity. Here's group 1, and this arrow indicates group 2. And here you see all eyes, 100% of them were 20/25 or better. And in group 2, the custom cornea eye was as good as or better than the conventional. Here you see. And this box outlines the 20/12.5 to 20/25 parameters. Here you see at 3 months the uncorrected visual acuity. Following now 2 months later, all eyes are 20/40 or better, and 85% are 20/25 or better. The custom cornea was better than the conventional eye in 4 out of the 5 of the group 2 eyes. So definitely it helped to change the algorithm, to tweak it, so to speak. Now let's look at a patient from group 1 and a patient from group 2. Here is the second patient in group 1. Total aberrations pre-op, it's a blue oval, so you know we're looking down into the bucket of a bucket-shaped wave map of a myopic astigmat. And post-op, the RMS drops dramatically, so we did a good job of getting rid of sphere and sill again. Higher order aberrations, just about double, not quite. Very typical for a conventional surgery as performed today. If we look at the other eye of the same patient, patient 2, we see total aberrations drop dramatically, actually swaying to the overcorrected side. That's why we see a little hyperopic hot bump in the middle. And we see that for the very first time, though, we are getting less than a complete doubling in the RMS. We're going up just 25%, so that's good. We thought, well, we're making some progress here. Now if we look at a patient plucked out of group 2, we see this person had an uncorrected acuity of 20/20 with a manifest refraction of +1/4 -75 at 17 degrees at 1 month. This is the conventional eye from the second group. We decreased the sphere and sill, so big improvement in total aberrations. Higher order aberrations, just about double. If we look at the mate eye for patient 8, we see we do a good job getting rid of sphere and sill, total aberrations go way down. And here we see for the first time in the US at least, we have intentionally and successfully decreased the RMS post-op as compared to pre-op. 0.22 to 0.15. So this is a tiny step in the direction of the supervision with the goal of improving on Mother Nature. If we look at the attempted versus achieved spherical equivalent, here's attempted and achieved and 1 diopter bars on either side, we see the conventional and custom cornea eyes arrayed as you see here, with the conventional being red and the custom cornea being the triangles, dark blue. And here if we look at patient satisfaction, here we see extremely satisfied, satisfied, not sure, extremely unsatisfied. So we see most of the patients are satisfied or extremely, but we have 2 patients that are actually overcorrected custom cornea patients, and they are awaiting retreatment. If we look at the quality of vision from significantly worse all the way up to significantly better, we see most people felt that their eyes had undergone no change and their vision quality was, okay, better or significantly better, but we do have a patient, a custom cornea patient, once again, who's overcorrected, who considers himself worse at the moment. If we look at the patient evaluation at 3 months, the distance correction was never worn for either eye after the surgery. There are no symptoms reported as significantly worse than pre-op in either eye. And if we look at which eye they prefer after surgery, all 10 patients, 7 of the 10 prefer either their custom cornea eye or they say both eyes are the same. 3 prefer their conventional eye. One of these 3 is a patient who says he prefers it just because it's his dominant eye. So if we look at the myopes in this assessment, the group 1 custom cornea myopic eyes appeared slightly overcorrected, and the algorithm was modified prior to group 2 to account for this, and some of those eyes are awaiting retreatment, as you saw, for overcorrection. The algorithm modification for group 2, however, significantly improved the outcomes for the custom cornea eyes. Also, the best corrected acuity was maintained. No one lost 2 or more lines of best corrected vision in any of the myopic eyes, conventional or custom cornea, and none of the hyperopic eyes either. Let's just look for a moment at higher order aberrations alone. Look at a post-op assessment of them. This is now all the myopes and hyperopes. 12 of the 20 patients had smaller post-op higher order wavefront errors in the custom cornea eye than in the conventional eye, which is a big improvement over the doubling or tripling, as I said, that usually occurs. 1 patient, a custom cornea myope, had smaller, higher order wavefront errors after surgery than before treatment, but none of the conventional eyes, and I showed you that patient. If we look at the average higher order RMS error, the custom cornea eyes had 0.29, and the conventional eyes had 0.35, so that was encouraging. And in summary, wavefront guided custom cornea surgery is a promising technology for addressing the aberrations of the visual system. We did a staged feasibility trial so that we would do no harm to these patients. We treated a few, learned, watched them, and then changed the algorithm, which led to improvement. We think that standardized test conditions are absolutely essential to evaluating the treatment efficacy, and that randomization of treatment for both eyes of each patient is the only really ideal study design. Algorithm modifications were identified and implemented at each stage of this study, and these resulted in improved visual outcomes for the custom cornea patients. Additional work is obviously needed to realize the full potential of this approach, and expansion of the study underway has been granted to us permission to go ahead with further modification to our algorithm. So we expect that we will inch forward a little more and improve the outcomes further as we expand. Thank you.
Marguerite, have you seen a correlation between the higher order, a reduction in the higher order RMS and the patient satisfaction? Now, when you reduce that in your later treatments?
Well, it's hard to do sophisticated statistics on such a small group of patients, but yes, our most happy patients are the people who are seeing 20/12.5, yes.
So with the lower the lower RMS values.
Yes, and which are correlated with the lower RMS values.
Did you do your Wavefront guided ablation with PRK or with LASIK?
With both, actually, but I presented LASIK results only here because the FDA wanted us to start with the LASIK patients, then do the PRK, and we've only done 13 PRKs out of the 20 spots they've allotted to us, and they were all so recently post-op we can't really say anything yet.
And do you think there's no difference between PRK and LASIK in that technology?
Well, once again, it's too early to say for sure, but we're encouraged that the first 13 PRK patients seem to be obtaining the same benefit from wavefront guided ablations as the LASIK patients. But time will tell whether there's so much stromal and epithelial remodeling that the benefit is erased. We don't know yet, but it looks good for PRK as well.